Hi, welcome to our first development webinar here at Uleska. My name is Gavin Fenton, and today I'll be covering the Docker Java library, which is a library that we find quite useful here at Uleska. A brief introduction. My name is Gavin Fenton, as I just said. I was the first developer at Uleska. I joined in June 2018, so I've been here just around 9 months now. I'm a developer in Java, React JavaScript, and I also use some Python, which we use for custom tooling here. I have a background in web application security, and during my time, I've been exposed essentially to a lot of different technologies. As a startup, I've been kind of exposed to the whole life cycle of our application, including just general development, as well as actually investigating new tools and really bringing them on board in our platform. And something I find useful is Docker. So what I'll be covering today, I will be going into a brief overview of Docker, what it is, what some of its uses are. Then I'll go into the Docker Java library. Then I'll go through some of the code examples, really relate those to how you would want to use it on a day-by-day basis if you were to integrate it into any sort of product. And then I'll cover some of the extra functionality, which I don't have time to go into detail on. And then I'll also look at some of the use cases, really why would you want to use this and why is this thought useful? So just to avoid any confusion, I just want to clarify some of the things that I won't be covering. So I won't be going into a whole lot of detail on Docker. I'm assuming there will be some sort of basic understanding in some of the concepts that I'll talk about. I won't be talking about how to Dockerize Java applications. In contrast to that, I will actually be speaking about how to run Docker with Java rather than traditionally the other way around. And then there will be some functionality which it might be of some use to you, but we won't have time to cover in detail. But I will, at the end, briefly mention anything that I think is the most useful. So, a bit of background on Docker. So, it launched in 2013, and really what it did was extend existing Linux functionality, namely control groups and namespaces for containers. And I'll go into a bit more detail in a second on what those are. It was later extended to Windows, which really means that you can run this natively anywhere. So you could traditionally run it on Linux, but then later on, whenever it started to get a bit bigger, Windows got on board and made it supported on their platforms. And that really means you can run it locally in your own data centers, or you can even run it in the cloud. Before containers, really the de facto standard for virtualizing applications was virtual machines. And the real problem that they were trying to solve is to allow for isolating resources and to allow for resources to be allocated on a per service basis. So really that means that you don't want multiple services on the same machine being able to say access the same files or use the same files at the same time, just in case you kind of end up with any sort of deadlock there, or you end up with conflicts. And you would also want to allocate the resources on that server. So, that would be things like CPU, memory, so that really if one service decided to go haywire, it wouldn't affect all of the other services on that box. This was achieved by virtualizing the hardware for server. In order to do this, it uses something called a hypervisor, which actually manages all of the different services running on that machine. And it allows for multiple virtual machines on a single server. So each of those would have a full copy of the operating system. And really that means that if you're running on one of those virtual machines, as far as that virtual machine knows, it is the only thing there. It feels like a full server. In order to do this, it needs a full copy of that. And that also means that it would need all of the necessary binaries and libraries that support its running. Containers came on the scene a bit later. So they really wanted to achieve the same goals as virtual machines, which is resource isolation and allocation benefits that virtual machines were able to give you. So as I said, it extended existing Linux functionality. So the first of that was namespaces, and this is what it does to allow for resource isolation. So that means, as I said earlier, you can't access files of another service from a different service. Just that really stops anything, such as if two are trying to access the same thing and one does something that affects the other. You don't want that, usually. And then control groups. So these allow you to allocate things such as CPU and memory. In contrast to virtual machines, they actually virtualize the operating system, not the hardware. So they don't try and pretend that there's multiple CPUs or anything. They can run multiple containers on the same machine, just in the same way you could run multiple virtual machines on the same virtual machine host. But some of the differences come in here. So they actually share the same operating system kernel, and that means that they don't require a separate copy. There isn't a duplication of files there for the binaries and libraries that I mentioned before. And via the namespace and control groups, they can still give all of those the same benefits. So here's just a little comparison between the two. So on the left, you can see how a virtual machine would be hosted on the same machine. So you can see here that there's two different applications, A, B, and C, and they all contain a copy of the guest operating system. And then the hypervisor controls that, and then that runs on top of the infrastructure. So you can see that the guest operating system takes up quite a lot of space in each of those. Whereas on the right-hand side, we can see containerized applications. So these don't require all of that guest operating system space to be taken up by a unique copy. You can see that the host operating system runs just above the infrastructure. Docker actually runs on top of that to control each of the services. And because you don't have to take up that much more space or resources, you can see you can kind of fit more applications on. So containers are a lot more lightweight. They save gigabytes of space from the operating system. And because of that, if you're going to be storing images of your containers or virtual machines, containers really are faster. You know, it's a lot faster to pull from a repository and push just because there isn't that much there. And then because of this, it's also faster to spin up. There's a lot less overhead. You're not having to provision a whole new version of a guest operating system and wait on that startup time. So these can be a lot quicker if you want to restart a service that might have went down, or if you just kind of want to scale up. So the Docker Java library. So this is an SDK for Docker. It's not the only one out there. There's also Docker Client, which was developed by Spotify, and Docker Java API. This one was first released on the 5th of March 2014, and I believe that the Docker Client by Spotify was released June of that year. So really the popularity of the Docker Java library over the Docker Client one, I would say, is a lot more to do with features rather than one beating the other to the punch, because they're both quite similar in their launch date. This one is the most watched and starred of the three on GitHub, and really its core purpose is to allow for programmatic use of Docker. And we'll kind of go into why this might be useful. So we can just get stuck in with the code now. So this will be some examples. I'll show you some of the code, and where relevant, I will show you the command that you could run in the terminal to actually achieve the same functionality. So you know what you were trying to do, that you could also do manually. So the first thing you're going to want to do is you're going to want to import your dependency. So here you can see a Maven formatted one. So this would go into your POM file, giving the repository you're going to, the artifact, and then the version that you want to put in. So obviously this could still be done on Grid or any of the other build tools that you're using. Okay, so just like running in the terminal, whenever you run in the terminal, you are using that terminal as the client. So that is what connects to the Docker host and sends commands to the host. So we're going to need to do the same thing here. So first thing we're going to do is configure our client. So one of the handy features of this library is that it gives you a default client config. And this would be much of the same options that you would use if you were using it in the command line. So connecting to localhost, probably not providing certificates to run on localhost, things like that. So this just really tries to get you up and running straight out. So it actually allows you to override that. So say you want to connect to a host that isn't on your local machine. And in the top line here, you can see that I provided what is given in the default one. But then similarly in the next line, it uses TCP to connect to localhost. But really that could be any server that you wish. There is a config that you can pass in. So if you have a config file here, you could pass in your custom one there. And then really all of the other options that you might want to specify, it should be tailored for. So we can give a registry URL. This will be your default registry that you would pull and push containers to and from. And then the login details for that. And as I said, there are lots of other ones that you might want to overwrite, and really this should allow you to do that. The next thing to do is actually to build the client. So we have built our config, and now we actually need to get our client, which is what we can use to communicate with the host. So once we build that, we get our Docker client object, and just like in the terminal, we can go in and get information back from the host just to make sure. So you can see there that as this is running on localhost, it has my machine name, which is Gavin Uleska, but it also gives this ID. This is much like going into the terminal and running the docker info command, and if you actually do that on both, you should be able to see that that ID and the machine name are exactly the same. So images. Before running a container, we need to pull an image. So an image is just kind of a static container. So really it's a container saved and stopped at a certain point in time. So that should have like all of the services that you wish to run. And in order to pull one down, we just need to give the image name. So you can see at the top, I've used the Docker info that I constructed before to list the amount of images that are in on my host. And you can see that that's 0. The next thing I'm doing is I'm giving a pull command, and I'm giving it the image name, which is Docker will say, and it's just a hello world type example. And I'm also giving it a tag, which is latest. So this should go to the registry, and it should pull down the latest version of that application. And the reason that I put in don't forget me is because if you forget this, it will pull down every version of that image, which can take quite a while. And then as this is an asynchronous function, I just need to await completion and then pass in the callback for it, which actually deals with saving the image. So if you were to do this internal, this is the command you would run. And you can see now, I'm kind of building back up my Docker info, and that's just to make sure that it's up to date. And then I'm just kind of getting the images again. So as you can see, it's increased from 0 to 1. And there's some notes. As I said, if a tag isn't supplied, so that's where we said latest, and that could be 0.1, that could be 1.0.1, just any way that it's versioned. If you forget to put that in, it's the same as going into the command line and specifying all tags, which means that you want to pull down every version of that image. The registry info will be taken from Docker config, so that's what we built up at the start, but it can be overwritten on a per pull basis. So this could be very beneficial if you wish to actually manage multiple registries. So if you have a QA one, a production one, if you just have all that kind of split up, or maybe you just kind of want to use a public one and a private one, that can all be handled here. You specify in a repository, and then you can also rewrite the authentication config and pass that in. So very useful for multiple registries with one client, rather than having to create a new one for each registry you might have. So the next thing is we need to manage our images. So we may want to check the details of the images on our host. We can get all of them, or we can just use filters to get the ones we want. So we know that we've pulled down an image, and that is Docker will say. So I can list all of the images on my host, and then I've given it a name filter. And this is just me making sure that that's pulled it down successfully. If I left that image filter out, we could get a list of all of them on the host. So that might be beneficial if you're wanting to, say, write custom reporting or monitoring on what images are actually on your hosts. And then below that, you can just see some of the toString call out there. So it kind of gives the SHA-256, which is just a unique identifier for the image. And it also gives you the tags and the sizes as well. This would be very similar to running Docker images. So Docker images would list all of the images on a host, and then we can also provide a filter there. And as I said, we can see that it's pulled down successfully because we've got our details back now. The next thing we can do is we can actually inspect our images to get all the information that's available on them. So there you can see in the top line how we would do that in Java using our inspect image command, or in the next line if you were going to do it through the terminal. We can also remove images using their ID, so this could be good for maintenance if you want to make sure that, say, you've filtered all of your images and made sure that there is none older than, say, 2 months old, or you only want to keep 3 versions. This could be quite useful. So now that we have our images, we can actually run containers from those. So from an image, we can spin up a container. So a good way to think about this is an image is essentially a stock container, and a container is essentially a running image. And in order to start a container, all we need is the image name. So here we can get the container started, or at least build up the commands to it. So the first thing we pass in is the tag of the image. We give an entry point. So this isn't always needed. So if you put down a public one such as Postgres, really the entry point would be whatever starts that service. But for the purpose of this demo, what I've done here is I've kind of put in a tail command for dev null, and this just pretty much keeps that service alive, as by default, if the process 0 on the server stops, then the container itself will stop. So this just wants to keep it alive. That won't die unless I stop it manually. And then I'm also giving it a name. So here I'm providing a name called Uleska whale, and that allows me to uniquely identify this. Or else I could use the string container ID, and that will just provide me a SHA-256 of the container, and I can use that then to pretty much distinguish it from all the other ones. And then I'm just calling the get ID to actually return that at the end. So this would just be like passing this command, docker create, and docker whale say tail, and then so that's just the entry point. That's the first command that is run whenever the container starts up. And just like in the terminal, it'll return ID. So to actually start our container, we've created it, but we haven't actually started it. We just need to give a name or ID. So as I just said, I have actually named that specific container Uleska whale. So I can provide that, or I can provide the ID that's passed back, and then I tell the Docker client to send the start command. Alternatively, as I said, the ID, and then there is the command that you could run in the console. Once we have the container up and running, we can start to execute commands against it. And this is where we at Uleska have found our main uses for it. So what we really do is we use it for building our custom tools, executing, and then kind of grabbing the outputs for those, so that, you know, we aren't kind of having config kind of go all over the place or kind of stay where it shouldn't be. We don't end up targeting the wrong business's application just because there might be some issue with config getting overwritten. So here we can see that we're actually building a command, and what it's doing is it's telling us what container we wish to execute this against. It's telling us that we want to get the standard out from. Then we actually tell the command that we want. So this is a hello world example. We're running a command called cowsay, and we're just going to say hello to everyone watching the webinar, and we'll execute that. So as I said, we can attach standard out, but we can also get standard error, and then we can view the output without really transferring files, but we could also kind of, if you export to XML during your command, we could use that as well. Okay, so now that we have actually built our command, we can execute it. And we're just going to note that this is also an asynchronous function. So it waits on the completion. So here we can see that we have attached it to byte array output stream. So that's where we're saving our output. We have executed the command, and as we've seen on the previous one, I just wanted to say hi to everyone watching the webinar. And we can see here that it successfully ran that, and we've got a nice image here, which is of the Docker whale. So it's a very basic example there, but you've kind of seen something that you might find quite a lot of use for. If you have a service running and you want to continue to execute commands and get output, this is a very good way of doing it. And this is just by running this command below. So that pretty much covers a good use for it, but one of the other ways, rather than just printing the standard out, is we actually could have tools that output to JSON or XML, and the Docker client gives us that. We can use the copy archive for container command, and that really just kind of goes to the container, looks for a file at the specific location that we have given it, and then it will just try and pull that down as an archive. Okay, so I've covered some basic functionality that we've been using for here. Yeah. But, as I want to really show the benefits, there's quite a lot of things that you can do with it yourself that maybe are out of the scope of what we have done, or some that we will be looking at in the future. And management, some of the other things we want to do is to build images. So we might want to programmatically build images. And, we could write a Java service which kind of goes and tries to discover, say, an up-to-date base image. That could be a new version of an operating system or anything like that, and then just kind of make sure that we can automatically build images from that. We can create images from a tower. So if we wanted to transfer, we could have, say, a REST endpoint which accepts tarballs and automatically kind of builds up an image from that. We could save images periodically. We could back up our images and use those kind of just if we wanted to kind of go in after and see maybe what had happened within an image during the build. We could automatically save those or push those to a registry. For containers, we could write something that can go and consume container logs. That'd be very beneficial for kind of just going and trying to debug what may have happened if a service has something gone wrong. We want to copy. We could copy files. We could have an upload service. Maybe if we wanted to customize something on that container itself, we could use this to programmatically upload files to the containers. We can also diff containers. So this might be very beneficial for troubleshooting. So one of the main uses for containers is that they're supposed to be immutable. So, if something goes wrong on one, you just kind of throw it away. But you can use diffing to essentially see what was the difference between a container that ran healthily and one that maybe kind of bombed out because something went wrong. And then you can also update container settings, such as like CPU and memory. So, if you didn't want to shut down your container while it was running, to actually update, say, the resource allocation that you've given, you could use this to actually go across all hosts and make sure that it updates it for each container while it's actually running. So if you notice that on average all of the services are taking up too much or more than expected CPU or memory, so rather than just simply spin up another container from that still won't have enough to run, say, maybe one service, you can actually just go and update it for all. Volumes. So volumes are really the main way to persist data for containers and across. So they can actually be containers themselves or an external file system, such as a file server that you might have on AWS, Google Compute, or pretty much anywhere else. And they can be mounted to single or multiple containers and even external services. So if you wanted a file system that shared amongst many containers or simply other services you could really use that here. Networks. All the containers will run on a bridge network, which means that all of the containers on the same host can really contact each other by default. But you can also kind of go and look at all of the other ones, such as host overlay, maximum, and then you can also provide dumps so that containers can sync. You really use this library to go across all of your hosts, across all of your containers, and really just try and monitor who can communicate. You can use that to make sure that you haven't configured anything, as well as to configure anything if there is an issue, and you can actually use it for testing. If you're using a custom network plugin, maybe you want to go on and connect to the execute command to ping one container from it, and really just make sure that you haven't misconfigured anything for security reasons. Something that I debated whether to speak about or not is Swarm. Swarm allows multiple containers to run as one service. So you have really a replication of a service. And what that means is you can load balances on those. And if one goes down, you can spin up new ones automatically. They can be multiple hosts so that, if a host in one location goes down, maybe there's a power cut at a data center, or even, say, if AWS was to go down one day, you could still have it on, say, Azure somewhere else. And it would have built-in. So the reason that I debated whether to speak about this or not is with Kubernetes. So Docker Swarm is really being essentially replaced what it is developed, and the Docker team have kind of said they're going to continue to work on it. Kubernetes is probably the standard for doing things like this. The reason I did go and mention if you're new to essentially replication and all these kind of terminologies that this tries to, rather than have Docker and these all at once, sometimes it can just be that easier just to kind of go swarm and then go over to Kubernetes and try and make sure that you're doing the same thing there. So rather than have to learn two technologies, it can really help you learn one. I'm going to go about that later. So I kind of covered a lot of the main features of it. So why would you want to use this? So some of these might seem more apparent at the end of this, as I kind of covered some of the uses. So there's containers. So that could be simply start a container, stopping it, doing it after a certain amount of time, doing that automatically just to make sure that none of them are just kind of sitting dead on the host. You could write custom logging, so something that kind of goes into different containers, maybe a different host, checks all of the images that are there, containers, and then you could write your own custom logging, or you could use it just to go and get all of the default logs provided by each of the services you are running. On top of that, you could build monitoring and reporting. So monitoring just to kind of make sure that people are actually alerted to anything kind of suspicious or anomalous that is happening. And then maybe monthly you want to kind of run a report on what you've monitored. And then, as I said, something we're really using it for here as its main benefit is to get output from tools. So we really use it for running open source and commercial tools within containers that we can kind of spin up quickly and then take back down once we're actually finished with it. And what we do is we just kind of run it, get the tool output, and then just kind of take it away again. And that stops from any config leaking over. Really just helps us kind of know that we aren't leaving kind of the logins or anything that we're using sitting somewhere, because we can just delete the container. And then another use that I've heard some using it for is integration testing. So really just kind of trying to coordinate the deployment of services. Say, if you're using microservices, make sure that all of the dependent services are up there. It's not something I'm too familiar with, but it is something that there has been some writing about. So if that's of interest to you, you can certainly just Google for it. So thanks for taking the time to listen to the webinar. If you have any questions, or if you want to contact us about careers, and if you want to speak to us about the platform, maybe get a demo, you can reach out to us on any of the contact details here, or any of us on the team at LinkedIn. So thanks very much for taking the time to listen. Hopefully there will be more of these development webinars in the future, so maybe you'll hear from me. And if not, thanks, and I wish to hear from you in the future. Thank you.